Effects of constructivist pedagogy and technology integration on student motivation and metacognition. Due to the vast expanse of constructivist pedagogy and its implementation, I will be referencing constructivists Dewey, Vygotsky, Piaget, and Bruner and their influence on my methodology and data collection. My research focused on the synthesis of inquiry-based learning, reflection, and technology integration according to how students utilize the SAMR model to develop their own lessons and projects in the 7th grade social studies classroom. This would require metacognitive skills perceived as too early for students aged 12 to 13, according to Piaget's levels of cognitive development. And while recent neurological research supports Piaget's theory, studies reveal that brain maturation does not confine cognitive growth to specific age groups, validating Bruner's developmental theory that cognitive growth can occur simultaneously and through one's lifetime, leading me to hypothesize that a synthesis of constructivist pedagogy with student-driven technology integration and reflection actually activates metacognition and motivation in students aged 12 to 13. My research questions included: how does constructivist pedagogy, student-driven technology integration, and reflection lead to metacognition and motivation? And is there a correlation in the number of students with the ability to obtain the highest levels of inquiry, technology integration, and student self-reflection? The study transpired in a small, rural, economically disadvantaged town where students are not consistently exposed to the educational use of technology until attending middle school. Middle school includes 6th through 8th grade, with each grade level divided onto academic teams. The student population on my team totaled 84, with 50 participating in the study. Of those 50, 32 were female and 18 male, an accurate representation of the team's female-to-male ratio. Service plans included 8 GIEPs and 4 IEPs. According to the 6th grade English Language Arts PSSA scores, 23 were advanced, 13 proficient, 10 basic, and 4 below basic. Statistical data required to include students with challenges beyond academics were not available for this study. Study methods included station rotation every 15 to 18 minutes with 2 to 5 minutes of physical movement in between. The concept of stations themselves are constructivist, with collaborative tables structured for peer mentoring and the sharing of learning through a variety of socioeconomic and cultural perspectives. The independent station for constructing new knowledge as an individual process, and the student-driven discussion table for facilitating what students need through an expert in the field. In the second half of the year and for the study, students began the open inquiry process, choosing topics from ancient Egypt, Greece, and Rome. This changed the classroom setup to groups which were assisted as needed in order to practice specific research skills as well as introduce technology applications. Scaffolding and differentiating lessons enabled students to discover learning both independently and collaboratively. To clarify a synthesis of data collection, analysis, and findings, I will detail each sub-study separately for the first research question and synopsize their integration with the second research question. For the pre-study period, I incorporated a system of inquiry-based learning steps inspired by Dewey, who recognized and implemented a deductive system for both science and history classes. Pre-study scaffolded mini-lessons incorporated a methodical approach to inquiry. Reflection occurred throughout the inquiry process with analysis of gathered fact, development of a project proposal, editing, and editing again after peer review. Quantitative data was in the form of an IBL checklist defining structured, controlled, guided, and open to track the number of participants to reach each level. The quality of inquiry was determined by the 8-step IBL rubric I created. Both forms of collective data were triangulated by an administrator and 3 educators. Figure 1 displays teacher-driven lessons scaffolded in order for students to build skills for open inquiry. The majority of participants met the intended IBL level for each lesson. Note that with the burial site project, 11 participants were not prepared for guided inquiry. For the themes of civilization lesson, 2 participants needed a structured system, while 2 others moved beyond the lesson and included research to their own questions. Data reveals that by the Ancient Greece project, 98% of students had the necessary skills to implement open inquiry, creating a fully developed constructivist classroom. Columns and graphs represent each step of the IBL process to determine the quality, with steps 1 and 2 combined as prior knowledge and posed questions. Graphic organizers were created to delve into the details of past units and to transfer prior knowledge to construct new learning in the form of posed questions and a thesis or hypothesis. The first 3 IBL steps mandated the metacognitive ability of transfer, which proved challenging, but not out of reach for students aged 12 to 13. Emerging students totaled 33 for steps 1 and 2 of the inquiry process, while step 3 totaled 29 emerging participants. With the Ancient Greece project, developing students rose from 6 to 21 for steps 1 and 2, and in step 3 from 7 to 28. Growth continued into the Ancient Rome project with 25 advanced participants for step 1 and 2, and a total of 23 advanced for step 3. Formulating a thesis or hypothesis with a focused research question or questions was the slowest in growth and displayed the least amount of growth overall. From the Ancient Egypt to Greece units, numbers decline in the advanced, developing and emerging categories with an increase by 7 in the initial category. This could be explained through the group dynamic or the topic chosen. By the Ancient Rome project, numbers increased to 9 advanced participants, 20 developing and 11 emerging, with only 7 participants initial. With Step 5 research, students struggled with paraphrasing and validating sources, but became more comfortable by the Ancient Rome project, with 24 advanced participants, 14 developing and 7 emerging. Growth increased consistently across all units and was acknowledged in student reflections. Step 6, analyzing and discussing research notes, was completely novel to students and required mentoring, including sitting with groups to develop the process. For the Ancient Egypt project, despite the rugged start, growth continued through the Ancient Greece and Ancient Rome projects from 10 advanced participants to 24. Project creation, Step 7, included a student-generated project proposal, materials list, calendar of due dates with a task list for each group member, and a student-generated project. This step was the only prescribed step in which 16 students did not submit a response. This number lessened for the Ancient Greece project, with only 8 students missing a project proposal, and decreased to 4 for the Ancient Rome project. The 8th step for the IBL process included technology integration. Unlike the requirements for the SAMR model, for the IBL process, editing projects was included. Quantitative technology data was collected in the form of a SAMR checklist. Observation sheets were completed by a 6th grade teacher, an 8th grade social studies teacher, and a 7th grade math teacher. In addition, checklists were validated by all of them and an administrator. The SAMR model was created by Dr. Puentedora to measure the level of technology integration in lesson planning. Utilized in the same manner as Bloom's updated taxonomy, educators develop instruction to incorporate technology pursuant to cognitive levels. Substitution is the use of technology as a direct substitute to pen and paper, and augmentation as a replacement with improvement, both requiring the cognitive skills of memorization, comprehension, and application. The fusion of technology and instruction at the level of modification is the recreation of lessons due to the technical application utilized. Redefinition is the complete reconstruction of assignments that would not be possible without technology. Both of these levels necessitate analyzation, evaluation, and creation. Similar to Bloom, each level has a purpose and is visited. However, the goal is to integrate technology on the levels of modification and redefinition as often as possible. The first set of data displays results for pre-study scaffolded teacher lessons. Though the lessons were designed to classify as substitution or augmentation levels, 2 students worked beyond requirements of the burial site project to complete a multimedia map of the student-generated site, and 8 students collaborated on the themes of civilization chart, adding videos, images, and maps to answer their own question about the themes of civilization. The second set of SAMR data exhibits project results according to how students used the model to construct their own lessons. Note that if applications such as Noodle Tools and GAF were included for each step of the IBL process, results of utilization of the SAMR model by students would have included all 4 levels. Using mostly Adobe Spark and Screencastify for the Water as a Resource project, 47 students reached augmentation while 3 obtained modification. By the end of the Ancient Egypt project, a total of 5 students leveled at augmentation, 29 modification, and 16 redefinition. What I hadn't taken into consideration before the study was student use of social media, such as Facebook, Instagram, and TikTok, to post their projects. I only caught it when I overheard participants discussing the comments being made.